reverse engineering cognition is, you say, the purpose of cognitive science, and I would
Yes.
agree as well. What are the exact like methods that we're going about to reverse engineer cognitive science? Because it is a immense task if you think about it.
Being a vegan, don't expect me to recommend that you start cutting up the heads of innocent sentient creatures. But there's a lot you can do with the head of humans
Mm-hmm.
without cutting anything up. And the fact is, here at McGill, they, not me, because I was already a vegetarian, they were doing things with animals way back 60 years ago that now it's a piece of cake to do it with a human being with non-invasive mental imagery, and they never found anything out. I mean, there was nothing that they found out that we couldn't have found out this way, or almost nothing. There may be some. Remember, we made a distinction between cognitive function and vegetative function.
Mm-hmm.
Vegetative function includes digestion, growth,
Heartbeat.
immune system, etc. Medical things. On medical things, I personally say I'm satisfied with medicine as it is now. Don't hurt anything to save me. But I can't say that it's wrong to do that. I mean, parents will have children who have terrible diseases, and it may be that you have to hurt animals to be able to cure their kids. Rarely, I would say 95% of the research in every area, including in cognitive science, is junk. It's you throw it away, it's not going to help anybody, it's not going to lead anywhere. But maybe 5% really will. And I haven't got the heart. I'm a vegan because I have a heart for animals. I haven't got the heart to deny humans that. I have no problem telling them that you don't need to eat meat to be healthy and survive. But medicine is another story. So for cognitive function, peeking and poking won't help at all. I mean, telling you where in the brain what is going on will not answer how it's being done. Reverse engineering is trying to figure out how it's done and why it's done, and the why comes from an evolutionary explanation and not from a biochemical. I mean, yeah, not just causal function here and now, but causal function in prior generations and what led to it. Okay, so the methods that I think work surprisingly, because a good part of the course is also showing that what's going on in the brain and what it takes to reverse engineer cognitive capacity is not just computation. So it's not just computation. There are other things I've already said. Sensory motor interfaces themselves are not computational. They have to be physical. And lots of analog things, lots of biochemical things, for example. You can synthesize dopamine. Pardon me. You can simulate dopamine, the properties of the molecule, et cetera, et cetera. But it's no more the molecule than the simulated ice cube is the ice cube, right? So what I'm saying is there could be real ice cubes in the head. I don't really mean ice cubes, but there's stuff that could be going on in the head that is real ice cube. And we have to figure out what they are. Computation is still the best way to do it. Even in his famous Chinese room argument, Searle said that what I'm criticizing is computationalism, which is the theory that cognition is just computation, nothing but computation. Well, sorry, he said that cognition is computation. And then he did his argument that in the Chinese room, you wouldn't understand Chinese, even if you were passing the Turing test in Chinese. Did that go by too fast, or should I
Can
actually
you
do it?
explain the
Okay, okay.
Searle's Chinese room argument?
Yeah, yeah, it doesn't, the fewer words you use, the better it is. He said something like what I eventually said afterwards with the Chinese dictionary. He says, supposing you had a a candidate that could pass T2, which means it could be a chatbot with you for a lifetime, indistinguishable from a real person. You could not tell it apart from a real person. Uh, and supposing it did it purely by computation, this is important. He says, just a computer can do that. Searle, because of the nature of computation, could do the same computations. I could find out what recipes it's using, and I could take the Chinese, if you're talking to it in Chinese, I could take the Chinese inputs, which are symbols, and I could manipulate them according to the rules, and then give you the output without understanding anything that I was saying. You may have asked me what does ban ma mean, and the answer may have been it's a striped horse, right? I wouldn't know that I was saying that in Chinese. So if I wasn't understanding it, then the computer doesn't understand it, and therefore cognition is not computation. He said it too strongly. He said, it's not computation at all. Go study the brain. Go bugger up a bunch of animals and do a lot of mental imagery. But the answer is that all he's proved is that it's not just computation. A lot of it can still be computation. And he called computationalism strong AI, the strong artificial intelligence, the theory that cognition is just computation. But in fact, he endorsed, and he was right to endorse, weak AI, which is the same as the strong Church-Turing thesis, namely, the computer is a very useful tool for testing theories, for modeling, etc., as we did with the rocket science. And so that part was right. And I still think that that's going to be the biggest component. We're going to be finding out, first of all, we don't have an exact idea of what it is that humans can do, but we have a good enough idea already that we've got our work cut out for us for a long time. You don't have to do the fine tuning on a particular cognitive task before you can start doing modeling for heading towards the Turing test. We already know enough, but doing in our work, for example, it turned out to be useful to have a computer model of supervised learning, and to be able to put into that computer model of supervised learning the stimuli that we give to our human participants, to see whether just in the stimuli themselves, there are some that are harder to tell apart and less hard to tell apart, because that we could do with the computer model. Okay, and stuff like that, it's still useful for. But in general, it's gonna require ideas. And in fact, you said weasel word without defining it. A weasel word. Do you know why a weasel word is called a weasel word?
Because
You know,
you can use it to weasel your way out of
yeah.
defining it.
That's the metaphor. But why is it called? What's the weasel got to do with it? Yeah, no, it's not. No, it's not that. I thought it was that too. It's not to weasel your way out. It's because weasels, who are carnivores, but carnivores. When I was vegetarian, I also ate eggs and dairy, and now I don't eat them. They eat dairy. They eat eggs, and what they do is they nip off the end of an egg, just nibble off, and then they suck out all the egg, the white and the yolk, and then leave the egg. So the egg has the shape of an egg, but it's got nothing in it. That's why these are called
That's
weasel.
a great metaphor, actually.
Yeah, it's a really good metaphor, except I don't like it because it's not very visual. Um, anyway, so what was I going to say?
You were talking about weak AI and and Chinese room argument.
Yeah, I've done that. What I was saying was that in the process of doing
We were
computer
talking about
model.
reverse engineering cognitive science and weasel words.
Yeah, that's the name of the game, reverse engineering. And you asked me I'm not an oracle. How are we going to do it? You have no choice but to do it with our brain, right? We're not going to be able to read it off the functioning of the brain by peeking and poking and figuring out what's going on where. That is, it's like an NP complete problem. You can keep on doing that forever, and you still won't. And in the end, of course, you can clone the brain, but then you still don't know how it works. All you can do is duplicate, right? So to figure out how it does it, you're going to have to use your own brain, and you're going to get a lot of things wrong. And the people that read my paper, The Symbol Grounding Problem, got it all wrong. I mean, they didn't even understand what the problem was. They kept coming back with ungrounded solutions.
Right.
And yet, I can't go figure, because I can't figure out why, because it seems to be simple enough to say sensory motor function, you dummy, not simulation of sensory motor function, but sensory motor function is what it needs. You can figure out what sensory motor function, what features of sensory motor function are needed to do it, in simulation mode. But a simulation, one of the answers to Searle that they used to give was, okay, fine, it can't, it's not a robot, but you can connect the thing that passes the T2 to a robot, and then you've got a grounded robot. Nonsense, nothing of the sort. And then the other answer, that was the robot reply. And then the other answer was, well, you can, since because it's Church-Turing thesis, you don't need to just pass the T2. You have to add in a simulated brain, right? So
Mm-hmm.
more squiggles and squaggles, and then that'll be the right answer. But nothing of the sort. I mean, then you'd have a a chatbot and a simulated brain, and nothing. I mean, it's still not connected to it still doesn't do what T3 does. So the answer there, for dummies, was it's got to be sensory motor because of T3, and T3 has to be robotic, and a robot cannot be just symbols. But there's still a hell of a lot you can do with symbols. I mean, uh, uh, the, the reason I start with praising computation before I start kicking computationalism is because you have to appreciate how much computation really can do. It's
Right.
enormous. It's a nuclear weapon. There's something that's even more powerful. What is it?
Language.
Yeah. And that's the interesting thing, that computation is just a subset of language. It's a syntactic subset of language. It's a thing that you can do with symbols, ungrounded symbols, right?
Right.
But it's useless as long as all you have is, I mean, a computer, if you set a computer loose on the world, it can't do anything. You have
Right.
to have users that can interpret what it is that the
Mm-hmm.
computer does. And so, yeah, so a second thread that I lost because I've come in and out of so many things that the yeah. So once you've realized that your task is to pass T3, real T3, throw all those citations of the symbol grounding problem into the garbage if they're trying to do it with symbols alone, including everything on large language models. I mean, everybody's come out and saying, yeah, they really are grounded. They conveniently leave out the word symbol, and they conveniently leave out the word sensory, but they somehow picked a metaphor, a
Mm-hmm.
weasel word, by the way, for which they call grounding, which is somehow how are words connected to their reference. But what they end up being connected to is more words,
Right.
just like in the Chinese dictionary
It's
going on.
recursion, right?
Well, it's recursion on symbols. I mean,
Mm-hmm.
what it is actually it's infinite regress, is what you mean to say.
Oh yes, that's what I meant. That's what I meant. Infinite
Yeah.
regress. Thanks.